We're going to do some more alkane examples. Here we're going to have a couple of different functional groups, and we're going to see and notice the difference in priorities and where the starting points are for naming organic compounds.
So starting with the top left, we go and number it 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5. So we have two that have a 6-carbon chain. Now we have to figure out which produces the least complicated set of substituents. To do that, I'm going to circle this original main chain. And what we're going to do is we're going to take a look at what substituents are left over. We have an ethyl group here. We have an ethyl group here. So if we were to go through and number it, on one side, I'm at the 1, 2, 3 carbon before my first chain, 1, 2, 3 carbon before my first chain. It's equidistant, and I have ethyl groups. And if I circle the other way, a similar thing happens. I end up with ethyl groups off the main chain. If we count, on one side 1, 2, 3, on the other side 1, 2, 3. So it actually turns out that this is the same molecule no matter which way we draw and name it. It ends up being the same molecule because of symmetry. So we might as well make it easy on ourselves. We'll go straight through the molecule. 1, 2, 3, 4, 5, 6. This is a hexane. We have in the 3 position an ethyl, in the 4 position an ethyl. So I have a diethyl in the 3 and the 4 position. Now note, if we, for example, did have a methyl group or a propyl group or something, when we deal with alphabetical order for naming, it's the actual group itself, ethyl. So it's not the di that actually determines where alphabetically this comes in the name. For the next compound, it contains an OH group. If we look that up, that's a hydroxyl or an alcohol group. In this case, it's going to be an alcohol group. There's no other functionalities, and it's got higher priority than most that we're going to deal with anyway. So we're still going to go and count the longest carbon chain. So it's 1, 2, 3, 4, 5. Remember that this is an oxygen. This is not part of a carbon chain. So the carbon chain actually ends right here. And this is a CH2OH. And so the carbon chain actually ends at this point. So when numbering, the oxygen or the alcohol gets number 1 priority in this case. So we're going to start the number 1 right here at this carbon. 2, 3, 4, 5. And now it's a 5-carbon chain, so it's a pentane, but it's an alcohol. So we're going to call it a pentanol, and we're going to indicate that it starts at the 1 carbon. Now you don't have to. You can call this just pentanol and assume pentanol, not pentanal, pentanol, and assume that it's on the 1 carbon. But there are other positions. It could be a 2-pentanol, a 3-pentanol. So it is better to indicate. The other one is instead of 1 pentanol is just to call it N-pentanol, and that indicates that it's on the number 1 carbon. IUPAC, this is the way that we want to write it. And if you wanted to write it one more way, you could say it was pentan 1 all. Since there's not much else on the group, this is a very simple way of naming it. If we had a lot of substituents, we may want to start naming it like this. We'll try the one in the bottom right, the OH group here. And same thing, name the carbon or number the carbon chain. 1, 2, 3, 4, 5. Any other way, this seems to be the longest carbon chain. The OH takes priority, so we're going to call that 1, 2, 3, 4, 5. We go through, and we see we've got the alcohol at the end, at the number 1 carbon, and we have a methyl group hanging off. So we know we have a methyl. We know it's at the 3 position. We know that we have a 5-carbon chain, so this is a pentanol. But if we want it to be a little more specific, and we should, we want to call it a 3-methyl-1-pentanol or a 3-methyl-pentan-1-all. And we should be more specific about this since we do have other substituents now on the chain. This is the better way to describe it. And now we'll try the molecule at the bottom of the page. We have a few different substituents on it. So if we go through our longest carbon chain, we got 1, 2, 3, 4, 5. Again, this is based off of pentane. But now if we go through, we see that we've got 3 different substituents essentially hanging off the base chain pentane group. The highest priority is the alcohol, so we can label this as 1, 2, 3, 4, 5, and we begin to write in the different substituents. I know that I have a methyl group, I know that I have a bromo group, and I know that I have an alcohol. The alcohol is going to be part of the base chain name, so I can call it pentanol. I know it's in the 1 position, and I will see what else is attached to it. The bromo is in the 4 position, the methyl is in the 3 position, and now by alphabetical order I want to piece this together. The bromo is going to come before the methyl group, and this is all based off of alphabetical order now. It's not based off of hierarchy, which one is actually more important. Now we don't care because the base chain name is where that comes into play. So when I put this together, I'm going to have a 4-bromo, 3-methyl, 1-pentanol, or like I mentioned before, a 4-bromo, 3-methyl, pentan, 1-all, and that would work as well.